everyone, once again welcome back to my YouTube channel. This is Unit 3 Magnetic Effects of Current and Magnetism for class 12th, and the topic which we are going to discuss today is Ampere Circuital Law. According to Ampere Circuital Law, if we take a line integral of magnetic field over a closed path taken in air or vacuum, then this line integral of magnetic field B over a closed path in air or vacuum is equal to mu naught times the current enclosed by this path. So let us consider that we are having a straight conductor XY such that I current is flowing through this XY conductor from X to Y direction. Now we have to consider a circular path. Let us say it is a uniform circle of radius R. So line integral of magnetic field over this path, that is closed integral B dot dl, is equal to mu naught multiplied by I, that is the amount of current enclosed by this path. So according to the statement, we are having closed integral B dot dl is equal to mu naught I. Now we need to prove this law. And in order to prove this law, we are having closed integral B dot dl, and we will solve this closed integral B dot dl straight away. Now dl is a small portion of length of the closed path. Now we have divided this closed path into infinite number of equal parts such that the length of each part is taken as dl. We know that magnetic field acts along the tangent to this circle, therefore dl is also along the tangent, therefore the angle between B and dl is 0 degree. That is closed integral B dot dl is written as integral closed integral B dl cos 0, that is angle between B and dl is 0 degree. Now B is equal to mu naught I upon 2 pi r, and this value is already calculated previously. So B is equal to, substituting the value, B is equal to mu naught I upon 2 pi r, and we are having closed integral mu naught I upon 2 pi r into dl. Taking mu naught I and 2 pi r out of integral, because these values are constant, we are left with closed integral B dot dl is equal to mu naught I upon 2 pi r closed integral of dl. As it is taken a closed integral of dl, that means if we are going to add up infinite dl lengths, then it turn out to be a circle. So the radius of circle is r, therefore on adding up all these small lengths, we are having a complete circle of circumference 2 pi r. That means we are having closed integral B dot dl is equal to mu naught I upon 2 pi r multiplied by 2 pi r, where 2 pi r is representing a length of a circular path which is considered. So now cancelling 2 pi r with 2 pi r, we are left with mu naught I. So therefore integral B dot dl is equal to mu naught I, and hence we have proved Ampere Circuital Law. But now we need to consider that this Ampere Circuital Law, integral B dot dl is equal to mu naught I, is independent of shape of the path. So in order to prove that Ampere Circuital Law is independent of the shape of the path, then let us consider once again a straight current carrying conductor such that current I is flowing from X to Y direction, and we will consider any arbitrary path of any shape. Now this arbitrary path is completed, so now we will consider a point P on this arbitrary path such that the point P is lying at distance r from the current carrying conductor. Now we will consider another point Q at a very small distance such that the distance of point Q is also r from the current carrying conductor. So we are having PQ such as a length of PQ is very small dl, such that this length is extending an angle of d theta. So it is subtending an angle of d theta with the loop, with the current carrying loop. So now we are having integral d theta, we are having this d theta angle over here, and we know from class 11th that angle is equal to arc upon radius, that is PQ is an arc of length dl, and d theta is the angle subtended at the center, and r is the distance of points P and Q both. So therefore, as angle is equal to arc upon radius, therefore we are having d theta is equal to dl upon r, and now cross multiplying it, we are having dl is equal to r d theta. Let us mark this equation as equation number 1. Now as we have marked this equation as equation number 1, now we once again need to solve closed integral b dot dl. We are going to solve this integral once again because we have to prove that closed integral b dot dl is independent of the shape of the path. Now once again, dl is lying along the tangent to this arbitrary path, and the direction of magnetic field is also along the tangent of this arbitrary path. Therefore, once again, the angle between b and dl is 0 degree. That is, we can say closed integral b dot dl is equal to closed integral b dl cos 0. Now we know that b is equal to mu naught I upon 2 pi r for the straight current carrying conductor. Therefore, we will substitute the value once again, that is closed integral mu naught I upon 2 pi r dl. Now taking mu naught I and 2 pi r out of the integral, so we are left with closed integral b dot dl is equal to mu naught I upon 2 pi r closed integral of dl. We do not know the length dl, but in equation number 1 we have found that dl is equal to r d theta. So now we are going to use that value, because in this case, if we will add up all dl values, we are not going to reach to any conclusion because the shape of this path is arbitrary. So substituting the value from equation number 1, that is r d theta, we are having closed integral b dot dl is equal to mu naught I upon 2 pi r closed integral r d theta. Now r is fixed for point p and q because r is same for points p and q taken under consideration. Therefore, we can take r outside the integral. So we have mu naught I upon 2 pi r multiplied by r integral closed integral of d theta. If now we will add up all these d thetas, that is all these small angles, we will be having a total angle of 2 pi r. So we are having mu naught I upon 2 pi, because we have already cancelled or r over here, so it is equal to mu naught I upon 2 pi multiplied by 2 pi. So cancelling out 2 pi and 2 pi over here, we are left with closed integral b dot dl is equal to once again mu naught I. So that means once again closed integral b dot dl is equal to mu naught I, which is indicating that only depends upon the amount of current enclosed by that path. I hope you have understood the article. If yes, then do not forget to press like, subscribe and share button, and do press the bell icon in order to get the latest notifications on my video.